In this problem, we'll be talking about matching heights. So we've got two stones that are being thrown from different starting heights, and we want to see what would it take to get those stones to reach the same high point. Okay, so a stone is thrown vertically with an initial velocity of 32 feet per second from the edge of a bridge that is 48 feet above the ground. The height of the stone above the ground t seconds after it is thrown is this equation. Okay, negative 16t squared plus 32t plus 48. If a second stone is thrown from the ground, not the bridge, from the ground, then its height above the ground t seconds after is given by g of t is equal to negative 16t squared plus v naught, or v sub 0, times t, where v naught is the initial velocity of the second stone. Okay, so what we need to do first is find the maximum height of both. Okay, so we'll do the first stone first. Okay, so we're finding the maximum height of the first stone. Let me write that down. Okay, maximum height of the first stone. We first need to take the derivative of this function. So let me write down this function, f of t equal to negative 16t squared plus 32t plus 48. And then the derivative of that function, f prime of t, bring down the 2, so it's negative 32t. This becomes 32, the t goes away, and this goes to 0. So this would be the derivative function. Okay, so in order to find the maximum height, the derivative needs to be 0 because it's going up, and then the velocity stops, and the height stops, and it starts coming back down. So when that is at 0, it'll be at its highest point. Okay, so we set negative 32t plus 32 equal to 0. Okay, move the 32 over, it's negative 32t equals negative 32. And then divide that by the negative 32 on both sides, and you get 1 second. Okay, that's how long it took the first stone to get to its maximum height. Okay, and what is that maximum height? So it happened at 1 second. Let's see what it is. We plug that into the original function, f of t. So f of 1 equals negative 16 times 1 squared plus 32 times 1 plus 48. Okay, so that is going to end up being, let's see, this is negative 16. These two make 50. This is an 8. This is 48, by the way. Makes 80. That's 80. So would it be 64? Okay, so the maximum height is 64 feet of the first stone. Okay, now for the second stone, we're going to do the same process. Okay, the function is g of t is equal to negative 16t squared plus v naught t. Okay, and now we take the derivative of that, and we will treat v naught like a number, like a constant. Okay, so the derivative is going to be, bring down the 2, make it negative 32t. V naught is some sort of number, so a number times t, you take the derivative, it's just the number that's left. Okay, so do the same thing as we did up here. We set this derivative function equal to 0 and solve for t. So it's negative 32t plus v naught is equal to 0. Okay, so we move the v naught over, that's negative 32t equals negative v naught, and then divide the negative 32, so t is equal to positive v naught over positive 32 because the negative on top and bottom cancel. Okay, so that's when the maximum height occurs. Okay, and now we need to figure out what that maximum height was, so we plug it into the original function, just like we did in the last one. So it'll be g, but this time we're plugging in v naught over 32. Okay, so that's going to be negative 16 times v naught over 32 squared plus v naught, that comes from here, and the t is another v naught over 32. Okay, let's clean that up. So this becomes, leave the negative 16 out front, or with the v naught. V naught would be squared, and then the 32 would get squared as well. So I'll just write 32 times 32 for now, because that'll make it easier in just a second for me. Okay, and then this term is V naught times V naught, which is V naught squared over 32. Okay, if we clean this one up, in other words, reduce this negative 16 and or just the 16, keep it negative, and the 32, we would end up getting negative V naught, and this becomes a 2 because this is reducing. The 16 is gone and the 32 becomes a 2, so the bottom becomes a 64. Oh, that should have been a square, sorry. V naught squared over, let's see, that would be 64, and then plus V naught squared over 32. Okay, you can combine those together, okay, by finding a common denominator. So it would end up being negative V naught squared over 64. And to get the common denominator, make that one 64 too by multiplying a top and bottom by 2. So 2 V naught squared over 64. And now they have a common denominator. You have 2 V naught squareds here. You have minus 1. So there's just going to be 1 V naught squared. Okay, and then you get 64. Okay, so that is what the height is in terms of V naught. Okay, we don't know what V naught is. I mean, that is squared right there. Okay, so we need to figure out this one has a maximum height of 64, and it says determine the value of V naught such that the stones reach the same high point. So if this is 64, then we've got to make this be 64 as well. So we'll set V naught squared over 64 equal to the height of the original stone, which was 64. We multiply through, we get V naught squared equals 64 squared. We could square root both sides, and then we would get V naught is equal to 64. So that is the value of V naught in order to make the heights of the first stone and the second stone, the maximum height, be 64. And that's it.